PoE HAT lets you run a Raspberry Pi with nothing but an Ethernet cable. How? Black magic. No, but more seriously, a special network switch or power injector puts DC power into the same Ethernet cable you use for networking, then the HAT converts that power into something the Pi can use. PoE is helpful because you can run a full Raspberry Pi anywhere with just an Ethernet cable, and you can do things like remotely turn on and off power if you have a managed switch like I do. It simplifies wiring since you don't need a separate power supply, and you can run all your PoE devices off a central UPS so they're resilient to power outages. In this video, I'm testing the new Waveshare PoE HAT for Pi 5, and I'll test it with a microSD card. I'll also see if it can provide enough power for the Pi with 1 and even 2 power-hungry NVMe SSDs. There are already tons of PoE HATs for Raspberry Pi. Unfortunately, with the Pi 5, Raspberry Pi moved the little 4-pin header over here so it's close to the network jack. Because of that, none of the PoE HATs made for the Pi 3 or Pi 4 work with Pi 5, unless you're a mad scientist like Ivan from Uptime Lab and love soldering wires to PoE headers. Raspberry Pi hasn't even updated their own HAT yet, and I mean, I'm kinda glad that this isn't the final design. I know I wouldn't trust one of these running anything critical. No, all kidding aside, that's an early prototype, and anyone who prototypes knows the first step is getting something working. Clean solder joints are nice to have, but if you left your flux in another room, working is better than clean. But since Raspberry Pi doesn't have an official HAT yet, weirdos like me who run their Raspberry Pis in racks have to rely on third-party HATs. Except there haven't been any of these until this thing came out. Waveshare released this PoE HAT Model F, a very creative name. But it's the latest in a line of HATs designed for Raspberry Pi, and this one moves the little power header down to the right place so it can plug on top of the Pi 5. But how well does it work? I popped one on my 8GB Pi 5 to find out, and I tested it with a PoE injector and my Aruba PoE Plus switch, and it worked flawlessly with both. But first, let's get it installed. It comes with 3 little thermal pads. One is thinner, and that's the one that goes on the main processor in the middle. The other ones are for the PMIC, the little power chip that gets kinda hot, and the RAM chip up top above the processor. Then there's a very thin heatsink that goes on top. It's probably the thinnest heatsink I've seen for the Pi yet, but since it's so big, it can probably still get the job done fine. It snaps into the same mounting holes on the Pi 5 that the active cooler uses, and it's nice and secure there. The PoE HAT is double-sided, and on the bottom side facing the Pi, it has the GPIO plug, the little PoE power header plug, and then most of the power circuit, like the giant transformer that steps down the high PoE voltages to the 5 volts the Pi uses. There's also a little 5-volt fan in here, but it just has 2 wires, so it runs full blast all the time. And hiding out back here is a little 12-volt header, so you can actually power a 12-volt device up to 2 amps straight off this board. Flipping it over, the top side has some more power circuits and a cutout for the fan, camera, and display cables, and the PCI Express cable. It's a nice little unit, and supposedly it puts out 4.5 amps on the 5-volt GPIO pins to power the Pi, so in theory we should be good to go for full power USB devices for overclocking and pretty much anything. We'll see if we can do all that, but first I just want to make sure the Pi will boot up using nothing but Ethernet. And before that, does it work in the official Pi 5 case? Almost, but unfortunately the HAT is just a few millimeters too long to fit in this cutout. That's too bad. Hopefully Raspberry Pi's PoE HAT will support the case, whenever that comes out. So if you want to use this HAT, it's best to figure out a case design that works with it, or maybe mount it in one of the many Raspberry Pi rack mount enclosures that has room for it. I put Raspberry Pi OS on this little microSD card and plugged in Ethernet using a little PoE injector I use for testing, and it boots. The fan immediately goes to full power, and here's how that sounds. And this fan will always stay spinning no matter what, as long as you have Ethernet plugged in with a PoE switch or injector. Like, here it is powered off, and the fan's still going 100%. But when I booted up the Pi, I checked the logs, and good thing there aren't any voltage warnings. Also, after running stress NG for a while, I checked if it had throttled at all, and it hadn't. I was also monitoring the 5-volt rail on the Pi using this command, and it showed the average voltage was over 5.1 volts, with dips only down to like 5.04 volts under heavy load. In all my testing, it never throttled, and I never saw any voltage warnings in the logs. I also checked on temperatures. My office hovers around 22 degrees Celsius. While running stress NG, the temperature of the CPU never went over 44 degrees. So that heatsink and fan are doing a good job keeping the Pi cool. But powering the Pi with nothing else really plugged in should be pretty easy. It's only like 5 to 8 watts of power draw. Will it run just as well with an NVMe SSD plugged into the Pi's new PCI Express header? Yes, it does. I decided to go with Pi-Moroni's NVMe base, mostly because I love their little flex cable design. Instead of a straight cable that gets in the way of the microSD card slot, it does a double 90-degree bend and gets out of the way. Two things I think are a little annoying though with this thing are, this cable is just so flimsy. Like compared to the one I used on the Pineberry Pi, it's almost like a piece of thin paper. And the other little annoying thing I've had on this board is there's no LEDs, so you can't tell at a glance if it's powered or if the SSD is being used. Not a huge deal, but there are some other nice touches. Like I really like how they included 4 little rubber bumpers. That way I can just stick them on the bottom like this and it won't move around when I plug things into it. And putting this together, I realized it'd be better to set up the NVMe base before the PoE hat, but oh well, it worked out. I plugged in Ethernet and it booted right up. And I had forgotten, but I already had PiOS flashed to the SSD on here and it booted right up from that. I didn't even have to clone the microSD card to the SSD first. If you want to do that, I have a guide for how to do that on my blog. But I logged in and ran some speed tests. I could get over 700 megabytes per second if I bumped the PCI Express bus to Gen 3. And if I ran some disk benchmarks while I was also running StressNG, hammering all the CPU cores, the PoE hat still had no problem. I didn't ever see the voltage drop below around 5.04 volts. And at this point, I wanted to move the Pi over to my nicer managed PoE switch. One of the coolest things about running a Pi off PoE is you can actually remote control the Pi, at least the power, just by turning on and off the power to that port. Your switch has to support that though, and my Aruba here does thanks to a viewer who sent it in a couple years ago, but it also measures the power to each port, which is really handy. So I booted up the Pi again, and it looks like it's drawing around 4.3 watts at idle, running off the PoE hat with an NVMe drive. If I shut down the Pi, the fan still spins and the power draw goes down to a little less than a watt. Under heavy load, doing the CPU stress test while running SSD benchmarks, the power got up to 9.4 watts, which still leaves a lot of headroom under the Waveshare's rated 22 watts. So with that headroom, I wanted to test USB. Now, the Raspberry Pi seems to automatically enable USB current limiting with this hat. I'm not sure if Raspberry Pi's hat will have that same default setting when it comes out, but that does mean by default, USB devices can only take up to like 600 milliamps of power. And that's not a lot. It's enough for maybe some webcams, keyboards, or other small peripherals, but one of the most power-hungry devices is an NVMe SSD over USB 3.0. I plugged in this SN750 SSD using a USB to NVMe adapter and booted up the Pi, and the first time it had some errors, probably because of that lack of power. I went in and edited the config file and I added this option, USB max current enable. I rebooted, and after that, it worked fine. Now, I should say one time while I was formatting the drive, it went offline, but it appeared again after rebooting, and I haven't seen that same problem since then, so I'm just mentioning that, but you'll definitely have to do your own testing if you want to power USB devices with this hat. But I formatted the drive and set up a test where I copied a 10 gig file between the PCIe SSD and the USB SSD. The whole time it was giving 250 megabytes per second, which is about as fast as I see USB 3.0 copies go. Checking on the Aruba switch, that was peaking around 10.8 watts, so still plenty of headroom, but I would still be cautious with how much USB current you draw. This PoE hat is a great way to get your Pi running without a power cable, and I can't wait to compare it to Raspberry Pi's own version once they get around to doing it. I'll post any other things I find on the hats page on my Pi PCI Express database, and until next time, I'm Jeff Geerling.